Morning, everyone. And I'm going to start with the presentation now. So this is Secure Code Review with Semgrep. So first of all, what is Semgrep? How did the name origin? Like what was the origin of this name? Uh, you guys, if you have used the tool Linux in which is called grep, you must be used in some way or like uh, whatever if you have worked in basically SOC or just if you have just used the tool, if you have used the operating system uh, Ubuntu or any related operating system which is based on Ubuntu, say Kali or Arch Linux or whichever, which is like a say if you have also used Macintosh, then the grep tool is there also. So basically, grep is you can say the idea like idea behind semgrep is grep. So semgrep is basically semantic grep, and semantic means uh, basically like you will have some kind of like logical capabilities to identify some logics and uh, some flows in the code or whatever patterns you have given. So basically, grep is used to search for patterns in files, uh, inside the files, or in file structures. And semgrep specifically does that for the code that you have given. So that was the origin of semgrep, basically semantic plus grep. So about me, I am Bishwajit. I'm a security enthusiast and I have about 3.5 years of experience into cybersecurity, mostly into offensive side of security, but uh, in the like past 1.5 year, I have started also into like cybersecurity engineering, which is basically secure code review, uh, configuration review, those kind of things which are covered into security engineering. So yeah, coming back to what is Semgrep. So Semgrep is a static code analysis tool that helps identify security vulnerabilities. It is known for its flexibility and ease of use, allowing users to create custom rules using code-like patterns. So there are a lot of there are a lot of like code review tools which you can use for static analysis of tools, basically which helps you to identify security vulnerabilities which are present in the code. So uh, vulnerabilities like XSS, SQL injection, business logic errors, IDORs, these kind of vulnerabilities you can identify using like patterns that are basically like say if you know some coding, uh, then when you write a code, say if you are like writing a code for like basic authentication, then there are some things that you write basically. So those patterns we use to check whether manually or if we are also using a tool. So in that like the we use basically patterns or pattern matching to find vulnerabilities in the code, right? So basically the tools, if you have heard about like Fortify, SonarQube, and other tools, so they have a great like a big database which has a lot of rules and patterns that is stored. And basically what it does, it runs the code and it tries to match the patterns, whether these like this pattern is present or not in the code. And in terms of that, it identifies the vulnerability which is present in the code. So semgrep is nothing but the same. Like semgrep is also doing the same. It has uh, some patterns, you write rules, and uh, on the basis of that rules, the code that you have given as input, it will identify vulnerabilities or anomalies or code smells uh, in the input code, and you will get the output. So the question arises why we should use Semgrep versus any other software like analysis tool or say secure code review tool, because there are a lot of uh, tools out there and which are basically you can say older than, or they have a like bigger database in terms of rules and other patterns than Semgrep. So why we should use Semgrep? Because there are tools like SonarCube, Checkmarks, and Fortify. So these are big brands. So if you have heard about these kind of tools, then yeah, like you must be knowing, if you have done some code review in your past, then you must have heard, or if you have worked with the like if you have worked with the developers team, then you must have heard about these tools, SonarCube, Checkmarks, and Fortify. So why should we use Semgrep? Like this question arises. The main reason is Semgrep is fast and lightweight, ideal for CI/CD pipelines without slowing builds. So one thing about Semgrep is it is very fast. So the tools that you saw, SonarCube, Checkmarks, and Fortify, they take like comparatively they take more time to run the code and uh, to basically identify the vulnerabilities. But with Semgrep, uh, it like the amount to run its like engine and to get the output is comparatively less due to like it is like based on grep. So the other tools which are basically they have a database and they uh, they basically do fingerprinting, but since Semgrep's engine is much like intelligent and it is based out on like pattern matching basically. That is why Semgrep is much more faster, and since it also has the capability to do semantic analysis or flow analysis, that is why it is nowadays you will find a lot of companies which are having a CI/CD pipeline are shifting to Semgrep more than these like old tools like Fortify, SonarCube, and Checkmarks. Also, the next thing is it is highly customizable with code-like patterns. So the rules that you write in Semgrep are say uh, like pretty intuitive. Like whenever you are writing a code, uh, you basically know like what is the next thing, or you have an idea in your head. So say you want to write a function that is basically opening a file, or it is like fetching some data from a file and then it is storing the data to another file. So the code writing code is pretty intuitive, right? You know the logic and you write the code. So it is same with Semgrep. So whenever you find a code, whenever you give a code in input, you see the flow of the code, right? You understand the flow of the code, and to identify the vulnerabilities, also you need to understand what is the flow of the code. So writing the rules in Semgrep also is that intuitive. So once you have understood that, say you have like identified a function which is basically used for say authentication, which is like a SQL code, uh, SQL query, which is basically fetching a username and password from the database or from the table, and then it is matching your username and password with the input that you have given to the username and password which is stored in the database. Then you know what you have to search for, right? You know there is the input is coming, there is a username and password, and it is matching with the username and password which is stored in the database, right? So you know the flow, you know what it is doing, and when you're writing the code, when you're writing the rules in Semgrep also, then you know what you have to look for. So that is why it is intuitive, uh, and also it is context aware. Scanning reduces false positives by understanding code flow. So yeah, other tools like uh, say SonarQube, Fortify, Checkmarks, they just have these patterns or rules. So the engine is not like I would say it is not very context aware. It does just fingerprinting of the code, like the code snippets which is present, and if that is matched, then it gives you like a hit. So there is a lot of false positives when you run the code. You'll find a lot of false positive which it identifies, and then manually you have to go and basically check whether this is a false positive or not, or whether this is like an actual vulnerability. So that basically increases the time to review the code. Like ideally, it should take less time because you're automating the tasks, right? If you just want to manually identify the vulnerabilities, then it is fine. But if you are using some automation in your CI/CD pipeline, then ideally it should reduce the time. That's the goal. But if it still is giving you a lot of false positives, then this is not good because it will basically increase the time that it is taking for you to review the code, and as a result, the build and the deployment of the code and go live will take time, and that will like uh, you can say that will hamper the business because it will create a delay if there is like a necessary build that is going to, or there is some necessary changes which is required, so it will basically increase the time for not for that. uh, Next thing is with Semgrep, it has like it is an open source version. It has open source version that has some premium features available at lower cost. So yeah, if you are integrating something with your CI/CD pipeline, so you have to uh, like you have to consider like what is the cost of the tool and what are the features that you require and what are the cost of that features that you want to uh, uh, basically add as an extra in your you can say arsenal, right? So the tools that are already present in the market are pretty in terms of I would say like the money that they charge, they are like they are costly than Semgrep, but Semgrep offers you a free version as well, which you can integrate or you can use to check whether you can whether you are liking the tool or not, and then if it suits your CI/CD pipeline or the uh, say if it's just a project that you're trying to do on your own, then if it's matching with your requirements, then you can go for a premium version, which is comparatively cheaper than other tools. And the last thing is like it is very simple to integrate with your CI/CD pipeline, since there is nothing much in Semgrep. Like it is the integration is just you just like there is like a central code repository. If you're using say a GitHub or GitLab, then you just need to add the Semgrep's binary in after that with in your CI/CD pipeline, and you just need to create folders where you will store the uh, different rules for every say vulnerability category, right? So if you want to make a rule for SQL injection XSS, business logics and other things, you just need to create like rules for that and basically paste in your central repository. So integration is very fast and very simple. So other tools take a lot of time to integrate. The time is more, and the integration is like complex. So and if you have like missed something or if you have not given enough permissions, then the just the pipeline will break, and again you'll have to do it from the scratch. You'll have to check a lot of things. Uh, so that is the thing that is also considered to select like a tool which you are integrating your CI/CD pipeline. So what is the agenda? So agenda is we'll go through the basics of SemGrep, then we'll move on to meta variable analysis for entropy analysis, and taint mode for flow analysis. So basics of SemGrep is like the basic pattern matching that we will learn in the SemGrep today. Next will be meta variable analysis for entropy analysis. So entropy is like a random, you can say like a random string. And the purpose for entropy analysis is basically when there is some hard-coded secrets like password, API keys, or say any other secrets in your code. So it is like a random thing. If it's like a CSRF token also, then also you can consider that is entropy analysis. So if you want to identify some hard-coded secrets in your code, then yeah, we need to have the capability of say entropy analysis in your secure code review tool. And the next thing is state mode for flow analysis. So as I already mentioned that since Semgrep also provides you semantics, like it basically understands, it has the capability to understand the flow of the code, and it has the uh, basically it is not just like looking for patterns and matching it. It also has some features that basically understands what is the flow of the code, and where is the data coming from, and where the data is uh, processing. So it has that features, so that can be used for uh, like that can be used to identify vulnerabilities like XSS or SQL injection, these kind of vulnerabilities where the data is coming from the user which is supplying the input, and then it is passed to a function or uh, say any other element which is processing that data, right? So for that, we need to have some flow analysis. So this is the basic syntax uh, that we use to build a rule in Semgrep. So it starts with this uh, this identifier called rules, and after that, since one thing I also must tell you that Semgrep is uh, the the syntax is a YAML file. Uh, it basically is stored as a YAML file. So if you have used tools like Nuclei, or if you have worked with any other YAML tool, so basically you must be having some knowledge of the syntax of YAML. So you have to basically follow that in Semgrep. Otherwise, you will uh, like see errors in the code. So as in Python also, you know that Python has some uh, basically you have to do indentation in the code, and the syntax is a little bit to understand it is a little bit tricky because you have to maintain the tabs and spaces everywhere where you add a new function or you make a new class, or say if you are writing an if and else statement, then you need to maintain the indentation and that. So in semgrep also you have to like make sure that the syntax is correct, the indentations are correct. Other languages like C, C++, C sharp, in that you don't need to like bother about the indentation and those things, but in YAML you have to like maintain that. So it starts with this the rules you have to like you have to uh, use the keyword rules and then ID of the rule that you are giving. So in this case, this is just a simple print, and then uh, in pattern is basically the pattern you are trying to match for in the code. So basically you write the pattern. In this case, I have just written the print uh, as a pattern, and then there are parentheses after that, and the message, you write a message. So once the pattern that you are giving is matched, so this message will print out. So the message is Semgrep has found a match. This is like the a default statement. After that, you also need to write what is the language, since Semgrep is aware of the content and the context. So you need to mention like what is the language that you are writing. So right now there are a lot of languages that Semgrep uh, supports, like Python, C Sharp, C++, Java, .NET. So there is a huge list. Uh, Even the languages that are used for basically in infrastructure as a code, like uh, that the codes that you are using for building an infrastructure, Terraform, or these kind of languages are also supported in uh, Semgrep. And then the last thing, you write the severity. So once the pattern that you have given is matched, so what will be the severity of this? Because uh, severity is basically identifying like whether this is like an error or a critical or just a warning or any other thing or just an informational thing, right? This is the basic pattern, a basic syntax of Semgrep that you write for rules. Next thing is how to match pattern, right? So in the right hand side, first of all, this you can see this the screenshot. This is from Semgrep Playground. So you can access Semgrep Playground using this link. I'll share this link with you guys. You can access this and try for yourself. So I'll just give you a brief overview. So in the left hand side, let's go to this. So in the left hand side, you can see here you basically write your rules. In the right hand side, you paste the code, whatever code you're trying to uh, test for, you paste the code in the right hand side. In the left hand side, you build the rules. So in the rules also there are basically uh, two methods that you can use. So one is the structure method, where Semgrep helps you to build the rule. So basically, what it does is it will give you this a nice looking UI UX where you can write the rule ID, language. You can select using the drop down. The severity you can select using the drop down, and also you can write the message here. And for building the rule, you'll also see there is like a nice looking UI UX that you can use. So here you can click and select the pattern or all rejects basically inside not. These are the things that Semgrep basically uses for pattern matching. But for now, we'll just move to the advanced section since it is much more intuitive and it will help you to build your uh, the rules basically much easier, I would say, because you will have the feel of like what you are writing. You will have the feel of that, and you will able to see what are the patterns and what are the things that you are writing. Like so you can see that. That is why generally it is preferred to use this advanced method where you can write your rules manually. So moving on to this, how to match a pattern. So first of all, uh, you write the basic syntax as like as mentioned in the previous slide, in the syntax slide. You write the basic syntax, and in the pattern keyword, after the pattern keyword, you write the pattern that you want to match. So in this case, I in the right hand side you can see this is a simple Python code which has four functions, uh, basically four print functions. The first is like printing a string, which is print something inside. So this string will print. The second print function will print the variable called var. The third print function will print two variables called var1 and var2. The fourth print function will print nothing, basically an empty string, you can say. So this is a simple Python code, and to match my pat pattern, like whatever I want to match. So You can see in the pattern, I have just written print. So let's go to the playground and see this live. How does it work? So once I have given this syntax, I can just go ahead and click on run, and this will match for the pattern that I have given. Okay, so you guys can see right now I have just given pattern as print. So that is why it is just matching with this print function. Okay. So moving on to if I want to match with the other things, like if I want to match this print string or this second print function or the third, how will I do this? It is simple and very intuitive. So the next thing is when I want to match with the other things in the print function. So before that, let me tell you about this ellipsis operator. Uh, excuse me. So basically, this ellipsis operator is very similar to uh, in Bash or any other like scripting language. If you have used the star variable, which is nothing but you can say like a wildcard character which matches with everything. So guys, if you have used, like, just give me a like cheers or raise your hand. So if you have used the wildcard character, so yeah, Bhuvan has used that. He knows. Daniel has also used. So you guys must have the idea what a wildcard does. So wildcard is basically matched with everything, right? So whatever you are giving as input, and if you are like writing a star, so say if you are using a function called find, or say if you are using functions like list or something like that, if you are using star, then it will basically match with everything, and it will basically print everything or open everything, right? Can we use regular expressions? Yeah, we can use regular expressions. Absolutely. As I already like already tell you, right? So basically, Semgrep is based on grep, and grep lets you use uh, regular expressions, right? So in Semgrep also, you can use. So ellipsis operator is nothing but like the very similar to the wildcard operator that you have used in Bash or any other command line or any other language. So basically, this is like three dots. You can see one, two, and three dots, and this will match with everything. So for example, here, if I add three dots here, so basically this will match with everything which is uh, in the right hand side in the code. Okay. So to give you like what this pattern is matching is like first of all it is looking for print. Okay, so there are four print functions, and whatever is inside the print function or the parenthesis match with that. So basically this pattern means match with everything which has the print function and everything under inside the print function. So that is why you can see this is matching with everything. So if I write something else, say if I write, say any, just try a try block writing, then ideally it should not match with it. So you can see you are seeing like this is a syntax error since I have written the try block but not the catch block. But uh, as I told you, like the Semgrep is content aware, so it will also tell you like this is a syntax error. But my point is that the ellipsis operator will match with everything. And since I have already written the print function, and inside the print function, I have added a ellipsis operator which will match with everything which is inside the print function. So you can see it matched with all the four print functions, but not with the try. try block, right? So next thing is, let's move to specific, uh, how will I match with this, the say only with the print function, which is the first one, which has some strings in it. So which is basically a string. So what will I do? I will uh, add two quotes and then the ellipsis operator. So I'm telling Semgrep that match with print, which has these quotes, and whatever uh, string is inside the code match with that. So if I run this, basically it should match with the first condition, right? So you guys are open to speak, like whenever you feel like you can, since I cannot see this screen when I'm presenting. So if you have any questions, just you can like go ahead and unmute yourself and ask me. Okay. So this case, it matched with the first one. So next is I want to match with the second condition, uh, where the print function is printing one variable, and the third condition where the print function is printing two variables. Okay. So let's try to match with these two. So what can I do? This is the condition that you just saw. Like I matched with the first condition. Before matching with the second and third, I'll introduce you to, yeah, so we were at the meta variables, right? So what are meta variables? So meta variable is a placeholder that matches any part of code. Similar to variables, it allows you to capture specific code elements dynamically and reuse them in rules. So say I want to match with a variable which is present in the code, or I want to match with, uh, in lot of code snippets, you will find there are like more than one languages that is it is written in. So in Python code you will see, or in Terraform code you will see there is a block which is written in, say, YAML, or any other, like any other, maybe written in JSON format, right? Or maybe you are writing like a PHP code which has some HTML in it. So how will Semgrep know that this is like the same code, or this the thing you want to look for it? How will Semgrep understand? Because uh, right now it doesn't have the feature where it will basically identify two codes at the same time, like two languages at the same time. So say if you have selected only Python, then it will only uh, search for the things which is written in Python, the syntax, which will it will like search for Python. But in the Python code, if you have written a code snippet which is in JSON format, then it will not understand like what is this, and it will avoid that. So for that, you can use meta variables. So that code block or that thing, you can just define that as a meta variable, and then you can use for further analysis in Semgrep. So Semgrep has that feature. So right now I'll be using this meta variable to identify these two variables. Okay. So here you can see a meta variable is like a variable. So you define that as a variable and you use the uh, like the operator called dollar, uh, and after that you just write the like variable that you want to define, you want to search for, and it is all in caps. So here, say I want to match with the say this second function or the first function, then what will I do is I write a dollar, and then I will try to match with uh, basically like this second print function. Okay. So if I run this, you can see like this is not actually uh, what we were expecting, because ideally it should only match with the second condition, right? So if you think logically, if you have given, if you have like you have defined a print function, and inside that you have defined a meta variable, so logically, what should it do? It should match with the second condition. Am I right? Do you guys agree? Like
Yes,
give me
yes,
a
sir.
yes or something. Yeah, right. So logically, it should match with this, right? But
Bro, I have a
right now
doubt.
you're seeing, yeah, bro.
Sorry to disturb you, by the way. Bro, like,
No, bro, no, no.
I just wanted to know that, look, right now you are just showing us the playground. So, and whatever we need to like find out based upon the pattern is the one parameter where we put, like input our like whatever the logics we need to put. So based upon that, it will test our in the whole code.
Yeah, that's correct, bro.
Yeah, so I just wanted like I never tried, like it's first time for me. So I just wanted to know. Let's suppose you have in the organization we have multiple source code or every like let's suppose one even one front page is like contains several source code of the like it's like it's have content different folders. So in
Mm-hmm.
that scenario, how like how you run the like this script, or you can say that this application, so that it goes to the whole folder recursively and test whatever that you want, like the patterns, how you match. Like I just wanted to know like how the things like.
So Semgrep, bro, Semgrep is like right now I'm showing you the Semgrep playground because for demonstration, and if you just have like a one code, say one code file, then it is easier for me to demonstrate. But Semgrep also gives you a binary which you can directly install using like GitHub or whatever tool you use. Uh, there are like releases also, so you can install it in your like whatever uh, preferred operating system. It is present in Linux, it is present in Windows, in Mac, and also as I told you, you can also integrate this tool with your CI/CD pipelines. So
What?
say whatever files that you want to uh, use or give as an input, you can give using the command. So I won't give like I won't I can also show you the command, but it is like very simple and like you have, if you are using or you are into cybersecurity, then you have used a lot of tools that takes input files, right? So it is very like very similar to that. So you write semgrep, and then you give input file. There is a flag called if or some. I don't remember that right now. You give the input file, and then you give the rules file. So right now, since I'm using the semgrep playground, I don't have to create a rules file. But if you are using the command line, the CLI, then you have to create a rules file and you have to save it in YAML format. That's it. And you give the rules file to it, and you run the command. And once you run the command, it will give you the output in CLI only. And there is also one feature in Semgrep that it you can like run Semgrep's Semgrep's UI UX in your local uh, you can say like local environment. So in, I think in port 8080 or something like that, it will give you a great UI UX where you will get to know like what is the uh, so you are seeing this UI UX, right? So similar to that, you will find a UI UX there as well. So whichever code you are giving as input, you will see like what are the uh, things that were matched. So right, like this only like matched in line one, matched with line two, Semgra found a match. Like this only you'll find the output there as well. Am I clear, bro?
Yeah, I got it. Like it's like new to me, but pretty much I clear it. Thanks for the like, explaining in the friendly way.
Yeah, yeah, no worries, bro. So yeah, so meta variables, I was in meta variables, and ideally it should only match with the second line, right? But it is not matching. So Why you may say why, but first of all, let's move to the third one, and then I'll move back to why it is not matching with the second one, because matching with a third condition is easier. So let's do that. What I need to do is, uh, you can see these are like two variables, var1 and var2, right? So if I want to match with these two, what I will do is I will define two meta variables, var1 and var2. So don't be confused here. I am why I'm writing only var1 and var2. You can write anything, like if I write x1 and x2, it will work the same. This is just a variable. Don't worry about that. Like it should be similar to this only. Okay, so this is just a variable, and I'm just telling Semgrep that there is a variable that you need to look for in the code, which is inside the print function, and the variable can be anything. That's it. Okay, so we have matched with the third condition, which is print var1 match with print var1, print var2. Uh, like you can see here also, we have successfully matched with it. So next thing is, this is a challenge, as I told you, right? So ideally or logically, it should work. I have like given uh, a meta variable inside the print function and in the pattern, and I am expecting it to match with this thing, the second condition, but it is not matching. So this is a challenge for us, and we need to match with the uh, say the second condition. What we can do is we can just go ahead and write print var. Okay, so it will match, right? But the thing is, I don't want to do it like this, because I am say I am a source code reviewer, I am a hacker. I don't want to just go ahead and like define all the print statements and then expecting, because I want to automate and I want to reduce the tasks, right? I want to make a general statement which matches with everything, right? If I'm going to write these rules or these cases for every single, say, print statements or whatever I'm trying to match, then this is not good for me, right? This is not saving my time. This is just increasing my time, right? Because I'll have to go ahead and look the things in the code and manually write everything. You're getting my point, right? What I'm trying to say. I don't want to manually write
Yes,
all
sir.
these rules, right? I want to make a general rule which matches with these condition, like this condition in every code. So for that, what is the solution? The solution is Semgrep has got you covered. Semgrep is really smart. So these kind of situations, you can use pattern not. So there is a feature in Semgrep called pattern not, where you can specifically write what you want to not match for in your code. So in the above condition, you guys saw that when I'm writing this and running it, it is matching with the first print function and the second print function, right? But what if I write pattern not, and then what I need to tell Semgrep is, okay, match with the second print function, but I don't want to match with the first print function. So for that, what can I do is I can go ahead, write a print function again, and then tell it that whenever you're seeing this print function which has quotes and something inside, like some string is inside it, don't match with it. and I run this, and I see, voila. So we have found a solution, and you can use this. Uh, this is like a better solution, I would say, than going ahead and writing the where, because this is like you can run this in a code, and you don't have to tweak this again and again. This is much better solution, right?
But bro,
So next, yeah,
uh, can we append like the second condition into the can we append the second condition into the first condition, like using the it like I'm just asking that, is there any kind of operators we can use, like and or XOR? Is there any kind of operators we can
no,
use
no,
it?
no, no. There are like no operators are present in Semgrep like you're telling, and or XOR. Uh, this is like a method that you can use.
Okay. So bit by bit, like
This is,
we can go
yeah,
bit by bit. Oh, got it.
yeah. So next thing is let's. I think you guys have like a basic gist of what and how you can write or match patterns in Semgrep, right? Am I? You guys are with me with that? You have you have a, like a basic understanding how you can match patterns. Otherwise, I can like give you some more examples, but I can explain you again. So I need to have like everybody's hand with me right now. Otherwise, like there's no point to move ahead. Am I audible?
Yeah, you are audible.
Yeah. So guys,
Yes.
please like if you are with me and if you have like understood till this far, if you have like gotten a
Yes, I understood,
the idea of
Vishwajit.
how it is working.
Yes, I
We go.
understood.
Okay. I think yeah, you guys have understood something. So let's move ahead and let's do some serious stuff, right? Till now we were only into basics. Let's raise a bar a little bit and raise our difficulties a little bit. Right now we are
Like,
moving to actual
yeah,
code
sorry, Vishwajit,
analysis.
for interrupting this section. And we have 10 minutes extra to end this section.
Okay, okay, cool.
Yeah, thank you.
So hard-coded secrets detected. So in this code snippet, you can see there is a variable called hard-coded key, where you can see there is a hard-coded string and there is a password and there is a username, right? So clearly there are two hard-coded secrets that are in like that are present in the code, right? So what we can do and how we can identify this. So meta variable analysis to the rescue here. What is meta variable analysis, you may ask? Uh, Meta variable analysis is nothing but it helps you to detect code smells and as I already told you, the entropy, because you can see this is a random string, right? There is nothing in common in this string and in this string. So how will uh, in like a engine will identify whether this is a hard-coded key or an API key or a password? So for that, you need to have some kind of entropy analysis embedded in your engine, right? So Semgrep has that, and using that, you can identify hard-coded secrets in the code. So code smells or unsafe flows by tracking the placeholders which have that uh, API or secret keys stored in them. So how we can detect? So detecting is uh, basically easy. So first of all, what you need to do is you need to uh, first of all I like define two meta variables. The one which is the string, which is basically the API key or the password or any other secret, and the other which is storing that. So here you can see in this case there are two meta variables, A and B. So B is basically the hard-coded secret, which can be an API key or a password or any other thing. And A is the variable which is basically storing that, right? So in the right hand side, you can see a hard-coded key equals to some random string, password equals to some random string. So in the left hand side, you are also seeing the same thing. The pattern is intuitive, right? So A equals to some meta variable, private string A equals to some meta variable. And then the important thing or the important part is you need to define meta variable analysis. This is a module in Semgrep which allows you to analyze the random strings. Then you use the analyzer entropy. So entropy is basically the module which checks for the random strings. And then you give the meta variable which has the basically the string or the password, that variable you like define that in meta variable. So here you can see it has identified uh, the private string and the password. Okay, and you can see and whatever message you have like defined, it will print it, like hard-coded secret key assigned to hard-coded key. So here $A means this the variable one, and then the next case $A equals to uh, password. So you can see like Semgrep is I would say like intelligent enough to identify uh, what are the variables that are assigning or what are the variables that are storing the secrets. Okay.
Bro,
Yeah,
I
bro.
have a doubt in that code. So in the pattern you mentioned that the pattern you mentioned that private string. So let's suppose that like if the variable start with the public name, you can say instead of public it will start with private string. So it will match that. But in the second part, it will like the password is like password equal to something. So how it was detected that like because there is no like prefix was missed for the private string is not there for the that password variable.
Bro, you can see in the right hand side in the code, the prefix is for the first thing you can see like private string is mentioned,
Yeah,
right?
yeah,
Private string hard coded key equals
yeah,
to some
yeah,
random
good.
string.
Yeah,
But in the password, you can see there is nothing.
I think.
There is only password equals to some random string, and there is
Yeah,
a username equals to also some like username equals to minus,
yeah,
right? So that is what like I told you, Semgrep is intelligent enough uh, when you are like using this meta variable analysis module. So it knows that you want to match with like a random string only. So if
okay,
I'm not if say if I'm not be using this meta variable analysis, then username also will match.
okay,
Username equals to this also will be identified, right?
okay.
Because in the first pattern you are seeing uh, $A equals to um,
B.
quotes equals to $B, right? Matlab, there is
Yeah,
something
like we
inside
are
the
passing
quotes
the.
as variable.
Yeah, got it.
But
So
since
it's
I'm using
basically
the
so it's
yeah.
basically bro mass because of the you mentioned that call the meta variable like modules and inside also you mentioned that entropy that things. So it will
Yeah,
try
yeah,
to
yeah.
find out. Got it, got it.
Yeah, so I'm telling now, like analyzer is entropy. So what are you trying to analyze? I am telling Semgrep that analyze the things which are random. Entropy means random. And meta variable, I have defined the second one, the second meta variable, right? So I'm giving the second as an input for meta variable entropy. So say
Got
if
it,
I
bro.
have removed this statement, these three lines, meta variable analysis, analyzer entropy, meta variable B, then it will match with username equals to minus also. Due to like time constraint, I'm not giving you the demonstration, but you can try for yourself. This will work. Like you can use some similar code like this, and you can define like this. You can take screenshots right now if you want, and then if you remove these three lines and run the same code, then you'll see username equals to minus will also match. So moving on to code vulnerable to XSS. So all of you, I think, are aware of XSS, right? Cross-site scripting injection.
Yeah.
Yes, sir.
Got it.
Yes, sir.
Yes.
Yeah. So do you know, like, all of you have done some of source code review, some kind of source code review? Do you know why the cross-site scripting injection or XSS happens? Why does it?
Yeah. Yeah. Like
Why does
I
it
see.
like why a vulnerable site is vulnerable to it first place? So
Yeah.
you must be knowing why. Like, so basically, uh, you give a input in some kind of a parameter, a search parameter or URL parameter, and then if the site is not, if the server is not like escaping the inputs, or it is not sanitizing the input, or it is not encoding the inputs, and it is directly processing your JavaScript or HTML code, then you can see your code will uh, like whatever function is behind which is processing. So your code will process and you can see some output. Like if you are using the alert function, then you will see a bar, yeah, like a alert bar, which is, or you can use different like XSS or JavaScript functions. You can also redirect to some other site, right? So why does it happen? So there is a source which is like an input where, excuse me, there is a source and a sink. So basically, what a source and sink is. Source is like an input field, generally a URL parameter or a search parameter or some other parameter in your page. And sink is basically uh, where your code is or input that you have given is processing, right? So in this case, you guys can see this is like a code, and here where emp equals to request emp. So you can see like this code is taking input as emp. So emp is a variable which is a user input. It is taking that as a user input, right? Then it is storing that in a variable called emp, then dataset.ds, a new variable, a new data type is created, dataset ds equals to du dot get office emp. So a function called du dot get office is called, and the emp variable is passed to it. And after that, lval output.txt equals to, here are the, this is a string, and you can see string concatenation method is being used. And you can see like emp plus uh, working with us, right? So in this case, can you guys tell me what is the source and what is the sink? Any one of you, can you
Like
try like to
you
identify
are
what is the
asking,
source and sink?
you're asking what is the source?
Yeah, in this case, like if I consider like there are like 14 lines of code, right? So can you tell me like which line is the source and which line is the sink here?
I supposed to be like the LB output dot text.
Yeah. So LB output or text, what do you think?
It's
It is source or sync?
storing the data, so that means it's easier to exploit because
Okay, so like I'll tell you guys. So since the seventh line is taking EMP as input, so this can be considered at source, and the ninth line, which is processing the EMP variable, is the sync here. Okay, so seventh line is source and ninth line is sync here. And right now, uh, okay, like how can I identify, uh, like manually, I can tell you guys like this is the source and this is sync, and this code is vulnerable to XSS injection. It- And why, you may ask, like because this is not having any functions like encoding functions or escaping functions or sanitizing. There is no functions implemented here. Like whatever data that you're giving an input, it is directly processing in the ninth line, right? So this code is vulnerable to, like indeed this code is vulnerable to XSS. But how will Semgrep know? Like I can identify this manually, you guys can identify this manually, but how will Semgrep know? For that, there is a mode called taint mode. And as the name tells you, like taint mode is used to detect taint flows. And what are taint flows? Taint flows is basically the flows which are like identifying source and sink. So Semgrep's engine is intelligent enough to identify which is the source. Like if you define which is the source and what is the sink, then its engine will like identify whether any functions like escaping functions or sanitizing functions is present there or not, or whether the data that you are giving an input is like it is like sanitized in some way or not, or it is just processed without any sanitization or escaping. So it is intelligent enough to identify those things. So, so basically, it helps you identify potential vulnerabilities as such as injection attacks, SQL injection, command injection, XSS, XXE by tracking how data flows from sources to sync. Taint mode help you with that. So how do you define or how do you use the taint mode? So you have to use the uh, identifier called mode, a keyword called mode equals to taint. Then uh, you have to define a pattern source and you have to define a pattern sink. So in this case, what is the source? I already told you guys, source is the seventh line, right? So you define where meta variable data equals to request, and whatever is present inside that, we are not like really concerned about this. So we just need to like check whether the data that uh, the data which is giving is sanitized or not. So I have defined the source, and after that I have defined the sink as the this line lbl output.txt. So dollar output.txt equals to something plus you can see like the thing that we are really concerned about is this variable emp, right? Because this variable is storing the input which user is giving. So you guys can see data, the meta variable data is the same here, which is a processing uh, in this statement, in the output statement lvl output.txt, right? So once I run this rule, uh, Semgrep will identify like potential reflected excesses, use ST, and it is also suggesting you why. Because when you are giving a message, and since I use the taint mode, it basically ran through these three lines of code and it checked whether there is any kind of sanitization function like HTML encode. So basically, HTML encode, it basically HTML encode will encode all your special characters like less than or greater than or say quotes, these kind of things it will encode, right? So it had identified whether you used this function or not, http utility.html encode. And since we haven't used this, it identified and it gave us a match and alerted that this is a potential reflected SSS because we haven't used any sanitization function. Next is moving to part traversal vulnerability. Uh, the approach is same here also. Part traversal is basically when you can give an arbitrary path and paths like etc password or etc shadow, these kind of paths which are storing sensitive data, the and if the server has not implemented any sanitization or it is not blocking these kind of inputs, then the path will open and you can see these sensitive files, right? So here also the approach is same, and let's see, let's try to identify here. Like you guys can check like the third line string file name equals to request a dot query string file name. This is uh, basically the source. Like since this is taking the input here, and on the eighth line response file request comma response comma file name comma map path. So map path is basically the function which is opening the file name that you're giving as an input. So after the downloads directory, it will, you can see there is a plus and file name, the same, the same variable here. You can see here also, right? So this is opening the file name that you're giving as an input. So in this case, third line is the source and the eighth line is the sink, right? So what we can do, taint mode again for the rescue here as well. Detecting part traversal, how? So same as like same as before, we define the pattern source. So here also request dot this request dot this dot. This means the ellipsis, and after that dollar variable. This is the file name. Okay, this is, and the pattern sink is map path, and after inside the map path there is like whatever is present inside the map path. So for that I have defined the uh, ellipsis operator. And since we haven't like we haven't used any sanitization functions or escaping functions here or encoding functions here, so Semgrep identified and gave us a warning that potential part traversal found unsanitized input is file name, the same file that we have defined. So you can see like I haven't, in the message also I haven't like given uh, like I haven't written the file name as variable here. Like it, Semgrep is uh, identifying it by itself, right? So Semgrep is intelligent enough to identify uh, like what is the variable that I'm trying to define and whether uh, there is like sanitization functions implemented in the code or not, like when I'm using the taint mode. Moving on, code vulnerable to SQL injection. So say SQL injection is, I think, the most common vulnerability you guys must be like using or trying to find out, right? So it is, I guess, the first thing, the first one of the first things that you guys try or we try like as an offensive security personals, right? So XSS, then SQL injection, trying to add single quotes or double quotes to break the query, right? So do you know like why does it happen, or how do we identify in the code, like how we can identify whether this code is vulnerable to SQL injection or not? Anybody? Or what are the recommendations that we give for SQL injection? Anybody?
Checking, bro.
Sorry? Can you hear me, guys?
Yeah, you are audible. I'm just checking that code.
Yeah. So, like, in general, like, what are the recommendations that you give when to remediate SQL injection? Can anyone tell me what do we do to remediate the SQL injection?
Yeah, like
Parameterized query.
remove the like special characters like star one equal to and
Parameterized query.
Yeah. That's one. What else? What else do we look for? That's a nice one. Parameterized query.
Stored procedure.
Prepared statements.
Sorry?
Stored procedure.
Pre-prepared
Prepared
statements.
uh, that are same, like prepared statements and parameterized queries are basically the same thing.
Stored procedures.
Yeah, stored procedures is also a thing that we can use. So in this code, can you I can tell you like this code is vulnerable to SQL injection, but do you know or can you tell me why?
I think it's a raw query.
We can escape it with single quotes.
Yeah, that's correct. So you can see there are two user inputs defined, right? So the one is size, other one is column, and we are taking size and column as input from the user in the second and third line, and in the eighth line where we are actually uh, basically building the query, we are using select column from. So this is like uh, the input. We are directly using that input. We haven't sanitized it, or we haven't basically done anything to remove the mal characters from the user input. We have like directly used the user input here. Select column from products where stock is greater than 0, and here also you can see size equals to the user input, the same size and the column. So this is pretty evident that uh, we are like directly taking the user input and dynamically building the query, and we are trusting whatever user is giving the input. We are not sanitizing it or removing any mal characters. So it is evident that this SQL query is vulnerable to SQL injection. There are two reasons why. The first reason is we are not sanitizing. Second is we are not using parameterized queries or uh, parameterized queries, or what is the other name for parameterized queries? Uh, I just lost it. So yeah, like parameterized queries, we are not using parameterized queries, and yeah, parameterized queries, and we are not sanitizing the user input. Okay. So manually we have identified this, but how will how or we can use Semgrep to identify this is vulnerable to SQL injection. So one way is we can use the taint mode as we used earlier, but there is also one more thing that we can try for a different approach. So this time we are using pattern not inside. Pattern not inside has got your back. What is pattern not inside? Pattern not inside ensures that a specific code pattern is flagged only when it is not inside a particular context. So here, basically, we will try to define that the context is this SQL query. So, and it tells you like it will flag you when there is a specific pattern not inside particular context. This is useful when you want to ensure that unsafe code like direct string concatenation, uh, which is uh, basically a vulnerable or very bad way to write SQL queries, which is mostly vulnerable to SQL injection when you are trying to find out SQL injection in a code. So generally, when a query is built using the string concatenation method, you can say like 99% of in the cases, it is vulnerable to SQL injection because to secure it, it is like really, really difficult. This like the query is breaking from somewhere and then it is again building. So it is like a very bad method to build dynamic queries. If you're trying to build dynamic queries, then always use uh, stored procedures is a better way to build dynamic queries or parameterized queries, you can say. So as I was telling you, like the unsafe code, like direct string concatenation is report only if it's not inside a block where validation or sanitization happens. So like what I told you guys earlier. So how can I detect it? So my approach will be to identify whether not in this query. So uh, if you are aware of like the PHP code where how can you identify uh, like how can you define stored procedures? You basically use this bind param function, right? There are there are placeholders in stored procedures which you uh, define with question marks. Say for in this case, if I want to make this a stored procedure, if I want to make this a parameterized query, then what will I have to do? I will remove this column, the column variable. Instead of this, I will write a question mark here also, and size equals to question mark, to two question marks. And then after that, when I am uh, basically binding the user input with the placeholders, then I will use the band param method, right? That's how I build a prepared statement in PHP. So in other languages like C Sharp, .NET, or Java, there are the approach is same, but the methods that you use are different. So there also you define a placeholders, which is storing the user input and a function which binds your user input with the placeholder in the that you defined in the SQL query, right? So right now I'm using two patterns. The first pattern is SQL equals to QUER query. So this is nothing but a meta variable here. An ellipsis operator is defined to consider whatever is present, the variables and the other things inside it, and patterns that are not that I'm searching for is question marks. So question marks, as I already told you, are the placeholders. And the other thing that I'm checking for is pattern not a bind param in the whole code, right? So since these two patterns are not present, question marks and bind param, we can uh, consider like this code is potentially vulnerable to SQL injection. So yeah, that's it. If you guys have any doubts till now, uh, the stage is open.
Hello, bro.
Yeah,
Can you please say how you are able to identify sync?
how I what
How you can able to identify sync?
how I can identify strings.
Sync.
Sync.
Yeah.
How I can identify sync? So where? Here or
Like
in which one you want to identify?
yeah, this one.
So how I am identify sync? So sync is where the code is processing, right? So source is where the input is coming from the user, right? So here in this case, you can see like third line is uh, string file name of variable file name equals to request dot query string. So requesting input from the username, and then it is storing in file name. And in the eighth line, like this is uh, this is just a like try block, so you can uh, like leave it for now. So just focus on the line 8. So you can see response file name request comma response, which means like whatever uh, this is basically a function to open the input, the file name that you have given. And map path function is to map the path with the file name or the user input that was provided. So what this function in general is doing is, so basically it will open this file uh, after like whatever file you have given as an input. It will append that after the downloads directory and open it. So how I'm identifying sync is like I'm seeing where my user input is processing. So in this case, you can see map path is processing my user input, right? So user input was file name and map path is processing it.
Yeah. Got it.
So this is how I identifying like where is the source and the sync. Any other doubts?
I guess we don't have any doubts here and everything's okay.
Great then. Like thank you everyone for staying with the session, and it was really great to deliver this, and you guys have been a really great audience. And one more thing, like one support from you guys, like there is a community called CyberSaiyans that we have, and basically what we do is we give some like sessions like this only, interesting topics like Semgrep or penetration testing, like something interesting in penetration testing, exploit development, EDR evasion bypass, these kind of things we try to deliver as session. We also are in future we are also are going to start like helping you guys how to prep for interviews. Say there was a guy who was telling like I want to transition from SOC to offensive side of security, then how he can do that. So basically that also we can help you guys with that, because in the community there are a lot and different kind of guys from say different sectors of security, from blue team, from red team, from purple team. So all of that like helps you to have like an knowledge how you can transition from one side to another side. And in the future also we are like we'll introduce a lot of interesting things for you guys that you can use for your benefit. And also you guys can also give back to the community, like whatever things you feel like you have learned a new thing, a new skill, or something you want to basically want to brag about. Yeah, I know this. So you can go ahead and give a session or tell us in the community like you have achieved something good or you have gotten a good opportunity. So for that I'll share these links, and you guys are free